Hello and welcome to Tribe Topper. In this video session, you are going to learn about electric field. So let's understand what is electric field. So just imagine there is an electric charge here, say a plus Q charge. If there is another charge at a very far off distance, then that might not be attracted or repelled by this charge. So let's say Q naught, a small test charge, is lying at a far off distance. It may not feel any impact of this charge. But when we bring it closer, and suppose it reaches in this region, now this charge being say a positive test charge is immediately repelled. It feels the strong repulsion, and the repulsion goes on increasing, the strength increases as you go on moving towards this charge. So when this starts experiencing that force, it means that this charge has now entered the region around this charge where its impact, its influence can be felt. So Q naught, we assume, is a test charge. So Q naught, which is a test charge, means which experiences, it's an observatory charge, it experiences the force, and Q is the source charge, means it is the source of the force. So all this region that I have marked, all this region around this electric charge within which its influence can be experienced is called electric field. So the definition is related to the impact of this charge. So we say the region of space around an electric charge within which its influence can be experienced is called electric field. And now we need to understand what is electric field strength. That means how strong is the field. So obviously the strength can be determined from what force, how much strong force the test charge experiences due to this source charge. So we define it as the electric field strength is defined as the force experienced by a small positive test charge. So we say the electric field strength E is equal to the force experienced by the small positive test charge Q naught. So this is the mathematical definition. So you can find out the electric field strength from F over Q naught. And in the last session, we had done the Coulomb's force. Now, because these two forces plus Q naught, or the one you can see, we can take it Q small q only. So because we have a plus Q charge here which is lying at a distance, this is a charge plus Q which is lying at a distance r from this source charge r, capital Q. So what is going to be the force between these two charges? That will be k q q by r square. And I say that the electric field strength is the force experienced per unit charge. Therefore, in terms of this KQQ, what is going to be the electric field strength? That will be F by Q. That means KQQ by R square divided by Q. So small q will cancel out. So your expression for electric field strength can be KQ by R square. Now you can use the first expression for electric field, or you can use the second expression for electric field in a problem based on what information is given to you. If you have to, if it is given that this much force is acting and this is the charge, so what's going to be the unit? Newton per coulomb, and accordingly you can find out the electric field. But if they give you the magnitude of a source charge and the distance of the test charge from the source charge, then you will directly use E is k cube by r square, where of course you know k is 1 over 4 pi epsilon naught in vacuum, and its value is 9 into 10 to the power 9. And of course, it is important for you to understand what will be the field shape for a point charge. So if you see, this is a point charge plus Q. The field lines are, of course, the field lines are radial. So they just go out, emanating out of this charge. And the arrows indicate they are going away from the source charge. For the negative charge, again you have a radial field, just like the sun rays, but they are all acting towards the source charge. So you have to remember that the field shape for a point charge is a radial field, number one, because it goes radially outwards, and these field lines radiate away in case of a positive charge and towards a negative charge. So that's all in this video session. In the next video session, you are going to solve or understand some of the problems based on electric field.